Alright, so this is going to be the full model roller coaster demo video. We're going to go through every single feature that the model roller coaster is capable of doing. And we're going to start with the panel completely shut off. So this is what you will see when you come up to the control panel and it has been turned off for a while. As you can see, our control power key switch is turned off. To turn our ride on, we're going to go ahead and flip the control power key switch to on. Now, the shutdown procedure dictates that you need to press the E-stop during shutdown. So the E-stop will most likely be pushed down. So what you're going to want to do is you got to pull up on the E-stop. And now we have our E-stop bus reset light turned on. So what I'm going to do is I'm going to go ahead and press the E-stop bus reset. So now that's reset. Now I need to reset the fault for the emergency stop being pressed. So I'm going to go ahead and push the fault reset button. This is acknowledge. So acknowledge that fault and we should be good to go. So now I need to put the ride into, I need to enable automatic motion on the ride so that we can start moving trains. So I'm going to go ahead and push the auto motion enable / ride stop button. So that just enabled automatic motion on the ride. And then I'm also going to enable our lift hill real quick and we should be all ready to go now. So we have our, just to recap, we reset our E-stop, acknowledged our fault, started the ride, and then also started the lift hill. So now if you come on over here to the control panel. All right, so this is the welcome screen that you'll come to when the ride is powered on. So what I'm going to do is I'm going to go ahead and click the Go to Main manual, and that is going to take me to our main menu screen here. From here you can navigate to all of the different screens that are a part of our HMI application, but for the time being I'm going to go to our transfer screen first. Now the general legend for all of the blocks that you'll see, so blocks being the different sections that trains can be in, is if the block is okay, it'll be green. Okay and not occupied is green. So that's just basically the block is idle right now. If the block is yellow, it's occupied. So we know that a train is sitting in there at that time. Now as far as the sensors go, when the sensor is yellow, that means that it has been triggered and the block is occupied at the same time. So it basically will remember which sensor has been triggered in the block zone. Now, if it is yellow and blinking green, that means that the sensor is activated in the block zone and is being flagged at the same time. So it's been triggered, and right now it is being detected by a train. It detects a train in its way right now. So as you can see, we have all three of our trains in storage A, storage B, and storage C right now, which should be where they are when you initially power up the ride. This is laid out in the startup procedure, or the shutdown procedure. So to start up the ride, what I'm going to do is I'm going to activate our track switch here. So to do that, I click on the move request switch to storage button. And then at the same time, I have to push the HMI enable button. And if you can zoom out a little to see the HMI enable flashing. So whenever you need to activate HMI enable to be able to do a feature on the panel, this button will start flashing so that you know that that is what you have to do. So if you ever click on something on the control panel and it's not doing what you think it should, be sure to look down at the HMI enable light because it might be flashing and that might be what it's requiring you to do. So to go ahead and switch the track over, I'm going to go ahead and push that and push the HMI enable, and it will switch the track over. So if we look over at the track segment, I'll go ahead and do that again. We switch the track, and then we'll switch it back over to storage. Now if you see, the way that the track switch actually locks is with these two sensors. So to know that the track switch is locked and in the correct position, both of these sensors must be triggered at the same time. And one of the faults that we can show on the ride is if one of those sensors is not triggered. So if I give the transfer table a pretty good sized bump here and cause this sensor to not be triggered anymore, like that, you'll notice that we now have a major fault on the screen. So this is your fault mode display that shows what kind of fault we have going on. So there's minor, major recoverable, and major fault. So to be able to see what just happened, we can go to here and we can see that the track switch unlocked from position B unexpectedly, and it tells us to manually reset the track switch before proceeding. Now, the track switch is already locked because I did that on purpose. So what I can do is I can, if you zoom out a little bit, I can switch our ride mode key switch, which is currently in transfer mode, and I'll switch it to manual mode. So you have to be in manual maintenance mode to reset major faults. And I'll just push acknowledge because we know that the track switch is fine in the place that it is, and we can go ahead and move on. Now, as far as the track switch goes, there's a couple other issues that can arise. So let's say that the track switch was not in the correct position when we faulted it. Well, we can go onto the transfer track screen here, this is the manual operation mode for the transfer track, where we can literally jog the track switch. And so if I click jog track switch backward, I can literally move that track switch. And if you go onto the to the track switch there, you can see that I can manually jog the track switch wherever I want it to be. And then the idea is that you just, to reset the fault in that condition, so if it came unlocked or didn't make it all the way over or whatever, what you would want to do is you'd want to fix whatever the problem is. So if the motor broke or whatever in the time where the track was sliding over and you had a fault and the track switch ended up like here, what you would want to do is you want to go ahead and go on in there and fix the motor. Once the motor's fixed, you can go ahead and jog the track switch forward to this position where you wanted it to be once it's done, and you can lock it in place. And now that it's there, I'm pushing the button and it doesn't activate the motor anymore because we don't want to, grind the motor. But so we're clearly locked because we know that the track switch is in the right spot, and then you would go in and you'd reset the fault. Now, once you switch back to the transfer mode, these buttons are no longer active. You can no longer jog the track switch in these conditions because we are not in the manual maintenance mode. As far as the other button on this screen goes, I just switched it back to manual mode, as you can see up here in the top. So if I wanted to jog the transfer forward and backward, I can just click this button and you can see the transfer motor says it's running, and we're jogging the other direction. So if we look at the transfer table over there, we can see it's jogging forward. Now it's jogging backward. And the forward-backward directions for all the motors is based on the forward flow, so the train would be moving forward because this is the front of the train. And then backward would be this way because this is the back of the train. So based on the direction that the train would flow through, that is the direction that these buttons will tell you to go. So that's just a basic overview of some of the manual features of the transfer track switch. This transfer switch will also not allow you to jog forward if there is a train in this zone and a train in the preceding zone, because the block system is still active even in manual mode. So anyway, back to where we were before starting up the ride. We want to go to the transfer track control screen, and we want to move our train that is currently in storage A here, and we want to move it onto the transfer table. So what we do is we go ahead and we tap on the move to transfer, which is flashing green because it's an option that we can do right now. And we go ahead and push that, and we have to push HMI enable at the same time because we're activating movement out on the course. We go ahead and push that, and the button turns yellow to say that it's executing the command right now. Now, once the train has parked on the transfer, you'll notice that the buttons turn back on, and we have a few more options now. we can move back to storage A because storage A is clear. And we can also move the train in storage B to storage A. So we can go ahead and do that now. And I'm gonna shift the train from storage B to storage A. You can see on the screen how the train has moved. This block is now clear. So that's ready for our next one. Now I can actually request the switch to the main circuit. So this is going to allow the track switch to slide over to the main circuit. So I'm going to go ahead and click on that and click on HMI Enable at the same time. And we have moved our train over to the main circuit. Now, this button is not flashing yet because we switched into manual mode. So whenever you switch into manual mode, it executes, it disables automatic motion in automatic mode. So we have to push our automatic motion enable / ride stop button here to reactivate that. And then we want to reactivate our lift hill too. So our lift hill is now able to run again. And now what we're going to do is our advance to lift hill button is flashing green because now our ride is started and our lift is started. So we go ahead and push advance to lift hill. And you'll notice if you look up over here, the train will advance into the lift hill and the ride will run normally. So basically on the lift hill, there's a little puck with a little piece of aluminum tape on it that pushes the car up the lift hill. Now this was actually a pretty big design challenge because I'll actually stop the lift right here. Well, let's see. Let's get a little higher. If you see right here, this is the little anti-rollback that runs the normal chain. Now the problem is that with these cross ties, I could not get the chain into this little area here to be able to engage that. The biggest issue is when you curve up. So when you curve up on the lift hill down here, the chain naturally wants to drag out of the trough. And what you have to do is you have to actually put a little guide over the top of the chain. If you see here, the little profile of the chain trough, I guess, has like this little piece that goes over, and that keeps the chain from ripping out of this area right here. And the problem is that these little anti-rollbacks are so tiny that I could not possibly get them to engage a chain and have this piece here at the same time. So I had to design these little aluminum tape lift pucks that allow the train to engage specifically just the lift hill chain. So that's the reason behind the lift pucks versus just using a normal anti-rollback system. I have 3 pucks on the lift hill as well to increase capacity, because the problem would be if you have the lift puck here come over the top when the train goes over, the next train would have to wait for the lift puck to come all the way down the lift hill and all the way back to the reset point, which is down here. This little sensor right here is the sensor that allows the lift pucks to be detected as they come through. So this is how we know where the lift pucks are, so that the system can identify that the lift is ready to receive another train. Now we can go ahead and restart the lift, I think. So going ahead to restart the lift. To stop the lift, all I did was push this button. This is the lift stop button. So this stops just the lift block. I can still move everything else on the ride totally fine, but this would be used, in the real world if you had, something that might be a safety issue on the lift hill, like a rider with their cell phone out or something like that. So we can go ahead and push the lift start button, and the lift will automatically restart itself and start climbing the lift and go on over. And the train comes into the station just like that. Now, to keep going on our startup here, we're going to go ahead and click request to switch to storage again, because we want to bring our next train onto the track. I'm going to just put 2 trains on for now, but we can run up to 3 at a time. So I'm going to go ahead and move that train over to the storage or to the track switch and switch it back on, just like we did before, and then advance it to the lift hill. Now, another feature of the lift hill that's pretty important is our lift tensioner down here. So if you look, this piece that has some rubber bands on it is actually keeping constant tension on the chain to make sure that the right tension is there. Now, there's a sensor right here that is detecting whether or not the chain tensioner is operating properly. So this is kind of there to make sure that the chain hasn't broken or something weird has occurred. So to kind of show something real quick here, I'm going to send a train into the chain or into the lift hill zone, and I'll show you what would happen if the chain tensioner failed. So let's say the train's just chugging along, moving up the lift hill, but something has happened and the chain tensioner no longer sees the actual chain tensioner here. So I can just go ahead and push that, and that caused this sensor to lose sight of this piece of aluminum tape here that's detected by this sensor. And when it loses sight of that, it causes a major fault on the control panel. So if you look here, back to our alarm screen, we're going to look at the lift tensioner sensor does not detect the lift tensioner. And the ride will remain in the major fault mode until the sensor detects the lift tensioner again. Because as far as the ride system knows right now, the chain has totally broken, and we have a pretty serious problem here. So to reset this, because I just moved I just basically just tapped the sensor so that it no longer saw it again, but it sees it again now because our alarm is not currently in alarm, which is what that little bell means. If that bell is highlighted white, it will say that we are currently in alarm, but we are not in alarm right now. And if the system thinks it's all right, when I push the acknowledge button here, the acknowledge button should not come back on, and we should be able to come out of the major fault mode. So I'll go ahead and push acknowledge, and we're back to okay. So that means that we're fixed, and the system thinks that it's operating normally. So to restart, because we had to switch to manual to reset our major fault, I gotta push my ride start, and I gotta push my lift start as well. So I'll lift start, and as you notice, the lift is moving again, and over it goes. So now, when you're starting up the model roller coaster, what you're going to want to do is you're going to want to check to make sure that the block system is working properly. So the block system is the system that's making sure the trains stay separated at all times. And the way that we can go through a quick test of the block system is we can go to our daily test screen, which is right here. This is our daily test screen, and this basically allows you to hold trains in a couple zones. So if I click hold train in brakes, what we can do is we can send a train. I'll go ahead and send it. And to send a train, I don't know if I've been over this yet, but you can go ahead and push and hold the dispatch button. And you must hold the dispatch button to enable any motion in the station zone. So the station block zone, to enable motion, this has to be held down. And if you let go, it will stop the motion. So if we want to take a look at the station, I'm going to go ahead and push the button and hold it down. As you can see, it sends that first train. But if we track the train coming in from the readies, I'm going to go ahead and let up on the button. Now, as you can see, the train isn't fully parked yet because the gates haven't opened. And that's because I let up on this dispatch button. If we come back over to the panel over here and look, the dispatch is flashing. And when I push and hold the button, I can move the train into the station and it'll park. And once it's parked, this light turns off, and then I can release the button, and we've done this full cycle. So now our daily test is still running right now, and we just held our train in the brakes. So if you notice up here on the brake run, our train is not advancing into the ready brakes, even though the ready brakes are technically unoccupied. So this is how we would test to make sure that the lift hill will stop where we want it to as it goes up. So if I dispatch a train from the station here and it moves around, what it will do is it'll come through here and we're going to actually see the train stop on the lift hill, because we can't allow the train to go over, because bad things will happen. If the train goes over and comes through the course, the train, this guy, if it went over, would come flying into the brake run and crash into that train, and that is just not a good thing. We could have really bad problems. So what you'll notice is that the train has automatically set itself up on the lift hill. Now, to disengage the train from being held on the brakes, I'm going to come back over here to our control panel, and I'm going to go ahead and click the Hold Train in Brakes button, and that is going to disable the train from being held in the brake run, and the train's going to advance forward, and then automatically our lift hill will start up again, and the train will come right on in. So now you'll notice that the train sitting in the readies is still sitting on the ready brakes, and that's because I'm not pushing my dispatch button to enable motion in the station. So I gotta push and hold my dispatch button to allow the train to move off the ready brakes. And then both the trains will park automatically. So now another step of our startup procedure would be to hold a train on the lift. So I come back to my daily test screen over here, and I'm gonna tap on my Hold Train on Lift button. And that turns yellow to say, hey, we're going to hold the next train on the lift hill. So if I go ahead and send the next train, and it'll send itself around the transfer. And this is basically simulating there being a train in the brake run over here. One of the features of this model is that you can dispatch a train while a train is on the lift hill, because we have this open transfer block here. So I'm going to go ahead and dispatch a train from the station, and it's going to roll around and park in the transfer zone. Now this is checking to make sure that the train in the transfer does not advance onto the lift block. So we now know, we have now run through a full test on the main circuit to show that each one of these blocks is operating properly, that the ride control system is not allowing the trains to advance into blocks that are already occupied. So what I'm going to do now is I'm going to go ahead and disable that Hold Train on Lift, and the train will automatically go on over the top of the lift. So we click on that and it's going. And now if we pull back to the actual ride itself, we'll see that once the next lift puck is detected down here, this train will automatically advance into the lift and run on up the lift hill. And up it goes. So you're not actually going to run the ride in daily test mode. You're going to run it in your normal operations mode. What you're going to want to do over here is once you're done with your daily test, you come back to the main menu, and we'll usually leave the screen in the overview mode. So this is our overview. This shows all of the items on the ride that seem to be things that you would look at normally. So I spent my time as a ride operator at Kings Island, and these are kind of the items that I found that I used the most when I was there, that I decided to put on our main screen here. So going down kind of our flow through here, we'll start with the ride overview, which basically shows all of the block segments. So every block segment in the ride. And you can see, brake run, ready brake station, some of the things that I've already talked about, transfer and lift. These are our main blocks on the ride course. So if we look back at the ride, I'll just go through. So brake run, readies, station, transfer, lift hill is the main course, and then storage A, storage B, and storage C out here. So back to our main ride overview here. We have the option over here to change the mode of our gates and our restraints. So the gates and restraints can be in two modes, auto or manual. So automatic basically means that whenever this train parks in the station, it will automatically release the restraints and the gates. To change that back to manual, which means that when the train parks, we actually have to push our gates and restraints push buttons to open that. I can just switch to manual here by pushing HMI Enable and the manual button at the same time. So you can see they've turned green here to say, hey, we're in manual for those two items. And now next time when the train comes in, which I can show right here, we'll see that the gates and restraints will not open. Give it 1 second, and we're parked, but as you heard and saw, the gates and restraints did not open automatically this time. Now, I've talked a little bit about the gates and the restraints, but we'll get a little bit more into it now about the gates. So this is the gates push button. This guy opens and closes the gates. So by pushing it, you toggle the gates open or close. So if we go over and we look at the actual station platform, whenever I push this button, it closes our gates or it opens our gates. Close the gates, open the gates. Now the thing about dispatching the ride is you have to have the gates closed to be able to dispatch the ride, because we don't want the guests who are waiting in line to jump into the ride area when the train is moving. So as you can see, when the gates are not closed, this light is flashing to say, hey, we should close the gates. We can go ahead and push on that button and it closes the gates. And once the gates are closed, this starts flashing to say, hey, we can dispatch. Now the restraints are a little bit more complicated than the gates, but they work somewhat similarly. So this button unlocks and locks the restraints. So to unlock, it would be, if they're locked, this button is solid, and what we can do is just push it to unlock it. Now you notice on the panel here, under our restraints, this is the status of our restraints in the train that's parked in the station right now. You'll notice that the restraints have turned blue to signify that, hey, the restraints are unlocked right now. That the fictional solenoid valves that are in the restraints would be unlocked. Now, this display is supposed to emulate monitored restraints, and monitored restraints are basically where if you pull the restraint down on you, there's a little limit switch inside of the restraint that once it reaches like a certain threshold that's considered safe to send, it will click on and say, hey, you're good to go. So what you'll see here is when I lock it, the restraints turn yellow first and then pop on green slowly. So the yellow signifies that the restraint solenoid is considered locked now. So when the rider would pull down the hydraulic restraint, we would be in the locked position. And then when they turn green, that kind of random turning on green, that's supposed to signify that the riders are pulling their restraints down and they're becoming locked. So as those limit switches would be clicked on, those are now locked. Now, let's say, for example, we have a rider who's too scared to ride and we need to let them off. It doesn't make a whole lot of sense for us to go back and recheck the entire train because any unlocked restraints would have to be rechecked by ride operators. So what we want to do to speed up our capacity is we only want to unlock the row that the scared rider is in. So what we do is we're going to go here and we have the option to release any of these rows. So I'm going to release row 2, and to do that, I just push on release row 2 and push the HMI enable button, and you'll notice that they've turned blue to say, hey, the restraints are now unlocked. To relock those restraints, I'm just going to lock row 2. You'll notice the button has changed to say lock row 2, and I go ahead and push and click, and they're yellow, and then they'll turn green when the restraints are pulled down. Now, you'll notice also on the lower panel that when the restraints are unlocked, dispatch is not flashing because we can't send a train when the restraints are all up. And then also, you'll notice that when I push the restraints button, the green light doesn't immediately turn on. And this is because we also can't send a train if any of these restraints are up. So if any of the restraints are, the solenoid is locked, but the rider has not pulled it down far enough to consider the restraint to be locked, we cannot send a train in that condition either. So once the system has detected all of these scenarios, right, that the transfer block is clear, that the gates are closed, that all 6 of the restraints are fully locked, that is when we can say, okay, we can send a train now. And that is when this button starts flashing green to say we are all clear to send the train. And then the ride operator would, of course, go, all clear, that means you're out of here. And then you click the button and it sends the people around the course and starts the cycle. So yeah, continuing around our overview display here. When the train is running on the course, we can see the location of each of our trains. Now, I've named all of the trains after fun spaceships in some of my favorite science fiction television shows. As you can see each block where the train is. So the Icarus right now is in the brakes, but it just switched over to the readies because it's making its way around the course. I can go ahead and send, and then Murata will leave the station platform and continue into the transfer, and then onto the lift, and it'll keep on going. Now, as you can see up here, the next box is the train and station display, and this shows you the pertinent stats of the train that is in the station right now. So right now, this is the train name that's in the station, so the Icarus is in the station. And the status of the train, and this can change if the train experiences a fault or something like that out on the course. This is the last cycle run time, so how long it took to get around from the top of the lift hill to the brake run, and then this is how many cycles it's run since I put it on the track. If we keep continuing up, we can see our capacity display, and this shows our most recent 2 hours of capacity up here. So the trains in operation say how many trains are currently on the main circuit right now. So we have 2 trains out there. We're running 2-train operation. Our current hour capacity says how many riders have ridden this hour. And our current hour cycles shows how many cycles we've sent this hour. So we have 42 riders this hour, 7 cycles. Last hour, we can also see last hour statistics down here. So previous hour capacity was 12, previous hour cycles, we only had 2 riders. Now let's say we're running the ride and we have an empty seat. So there was like a group of 3 and it left a single rider empty. We can go ahead and click the empty seat, and it will deduct 1 from our current hour capacity. So if you can see, we're now at 41 riders this hour. If we are going to send a fully empty train, we can go ahead and click on the empty train button here, and you'll see that it deducted a full 6 riders from our current hour capacity, and that's just to say that we didn't have the full train there because we don't want to count riders that we didn't have. So yeah, that's our overview display that kind of shows where everything is, and this would be the display that I would expect a normal ride operator to usually leave it on. If we go back to our main screen here, we can also go to our system stats screen, and the system statistics screen shows us a little bit more information, more detailed information about how the ride is working. So we can see our capacity, our hourly capacity for today and yesterday as well. And it shows based on the hour that it ran. So if, say we ran cycles during hour 23, which would be 11 p.m., they would show up down here. And then we get our totals at the bottom for how many cycles and how many riders we had in that day. Now also we have our master cycle count here, which you can see 1,312, and the last system boot time down here, which shows the last time we turned on the ride system from like a full power cycle of the PLC. This is the trains. This shows pretty much the same info that was showed on just the train and station display, except these are actually clickable. So you can tap on them and you can go to a more detailed display about the statistics of the actual train itself. So here we can see the status of the train, the last cycle runtime, which is in milliseconds, the total cycles that the train has run, the current block, just like the normal thing, but also we have the last 50 cycles of runtime data for the train. So you can see it's the timestamp of the last time the train went around the course, or the time the train went around the course for the cycle, and then the runtime in milliseconds that the cycle took to get around. As you can see, we're running pretty consistently at around 2.7 seconds. So on this screen, we also have some configuration. We can change the name of the train. So if we wanted to modify what our train's name is, we can go ahead and tap change name. We can type in a new name for the train. We can load save data, which I'll show you guys a little later. And then we can enable and disable train, which is used in unsupervised show mode, which I'll also show you guys a little bit later. So to get off of this screen, we go ahead and go to main. As we keep working down our normal operations display, the go to train stats display gives us the option to go to any of those 3 trains display without actually going to the system stats screen. So it's just the same screen that we had before. We tap on one of the trains and it takes us to that display. And you can go to any of the trains, including the ones that aren't currently on the track. And then, of course, go to welcome, takes us back to our welcome screen here. And yeah, so now that we've gotten through that, we can go to our advanced operation. You guys have already seen the transfer display, which we use to move around the trains. But it gets a little bit more involved when we talk about manual mode. So we're going to go ahead and talk a little bit about manual mode now. So as far as manual mode goes, if you click on any of the blocks in this zone, you can pop open its manual mode display. And that is even true in our overview display. So if you go to our overview display here, you can tap on any of these block zones. So like the ready brake, I want to see what's going on in the ready brake. I can tap on that, and this is its manual mode display. From this display, I can see a lot of information about what's going on in the block zone. For example, what speed the motor is running at. So when I go ahead and dispatch, you'll see that the motor will turn on when it's clear, and it will ramp up to 255 and then ramp back down. So it'll show you the current speed and whether the motor is started or stopped. And then, of course, the current status of the sensors. Now here's a cool example of our block system still being active in manual mode. When I go ahead and push jog ready forward, you'll notice nothing happens. As you can see up on our zones up there, the ready motor, or the block in front of the readies, is occupied, and that means we cannot move the ready train forward. The only way to be able to move the ready train forward would be to turn everything back on, move our train out of the station and into the next zone, and then switch back to manual mode, and now you can see the train is able to be jogged forward. Now, because that block is only able to move forward in normal operation, this certain block does not have the ability to go forward and backward. So I can go ahead and switch back to automatic mode and advance the train all the way back into the station just like normal, and everything will run fine. So this is the ready brake display. You can also access any of the specific block zone displays by going to their display under advanced operation. So go to lift, station, ready, and brakes. All of the transfer zone blocks are configured under the actual transfer zone display, so you do have to go ahead and come into the transfer track control display and then click on their blocks on this display to go to storage A, for example, storage B, and storage C. In this, and then also our transfer, which we saw a little earlier. So yeah, let's see. So as far as the condition where you need to take a train fully off of the track to be able to do maintenance on it, we can do that in full manual mode. So I'm in automatic. I need to turn my ride mode key switch to transfer, and then I'm going to turn it all the way to full manual. And that enables our add or eject train from system display. And this display you can only use when there's a train in storage C, because that is the train that we're going to allow to come on or off. So to be able to get that train to leave the track, I'm going to tell it to eject the train. Now this will actually derail the train, so be careful with this button when you're in manual mode. So I'm going to eject the train, and it will advance the train and cause it to derail. So now I can take the train off, and I can take a look at it and, inspect it and be like, oh, well, it looks all right to me. So once you've inspected the train and considered it good, we can go ahead and put her back on. What you can see, actually, real quick, is that on our system stats display, we can see that our last train here is now offline because there is no train being occupied by that placeholder for the 3 active trains on the track. There is no active train there. But have no fear, all our data logging has been saved, because in here we can see that our endurance train has been added to our data logging setup here. So to put the train back on the track, we're going to go back to the transfer display, and I'm going to go ahead and pre-thread on about 3 cars, but be careful to not allow it to detect on this sensor, otherwise you will cause a fault. I'm going to go ahead and click Add New Train, and it's going to start the motor up, moving, and I can just go ahead and load the train on just like that, and it'll park in the block zone. So now if we go back to our system stats display, we can see that we have a new train online there. Now, if you were just setting this up as a brand new train, you could just come on in here, change the name to, new train, and say okay, and you're done, right? That's all you need to do. But we are not a new train. This train has been run before. So we are going to actually load saved data that we've saved in the PLC onto this train. So what we go ahead and do is we click on our load save data display, and this pops open. You can save up to 10 trains in memory to go ahead and load later on. So because this was the endurance before, the train name sits in the PLC with all of its stored data, and what we can do is we can just click on the endurance, and you can see that all of the data that you had before pulls right back in and loads into the profile for this train. So we can go back to our system stats display, and you can see on our system stats display we now have all 3 trains on the track again, and we are good to go. So this is basically to allow you to take trains on and off and have like a good set of trains on station. So you can have some on the track, some off the track, etc., etc. All right, so the sensors on this roller coaster are actually pretty advanced because they're laid out so that we can detect a lot of different faults on the ride. So what I'm going to do is I'm going to actually go ahead and trigger a fault right now because this is a model roller coaster and we can do that. So I'm going to go ahead and dispatch just like normal, send the train, and bring the next train in. And now I'm going to act like, some random thing flew in front of the sensor and triggered it unexpectedly. So I'm just going to pick, let's see, probably this sensor. Now I'm going to come down here and I'm just going to put my key in front of it, which triggers the sensor. Now, what that did was the whole ride is now stopped. And why? Because the computer is now confused. Because it expects there to be a train here and there to be a train there. It does not expect a train to be over here. But that sensor right there just told the computer that there was a train in that block. And so because we had some confusion, the computer decided to take the safe road and just stop everything. So, and on the screen here, if you come on over to the screen, we can go ahead and take a look at what the operator would see. So as you can see, this is the sensor that I triggered unexpectedly. And it's flashing red to say, hey operator, this is the sensor I had an issue with. So if we look over here at our alarms screen, we can see that the brake 3 sensor was triggered because it is looking to make sure that the sensor upstream of it, or the brake 2 sensor, was triggered before brake 3, because that's the order that the sensor should be triggered in. So there should never be a time where brake 3 is triggered before brake 2, because as the train is advancing forward, it has to trigger brake 2 first before brake 3. So if we trigger brake 3 first, we know that there's something not quite right, and so we stop everything and wait for an operator to come around. Now, because I am the operator and I know that nothing is in front of that and that that sensor is operating properly because I personally triggered it, I can go ahead and push the acknowledge button, and as long as the system agrees with me, I can go ahead and push that, and because the system agrees, you can see the light doesn't turn back on because there is no actual fault going on. So there are actually multiple faults on each of the sensors. There are 4 faults that each sensor can pick up on. There is the upstream fault, which is what we just saw. There's also the downstream fault, which occurs when a sensor that is downstream of the train in the block is triggered. So let's say, for example, I trigger this guy right here. You can see that we now have a downstream fault detected because the train that sensor is downstream of the train in the block, and we can say that, hey, that sensor should not be triggered because the sensor in front of it was triggered. So yeah, that's a downstream fault, and because I triggered that, I can go ahead and push the acknowledge button and say we're all good. So now there are a couple more faults that I can't really show you while it's running because it has to be running, and they usually don't occur when it's running, but we can kind of see what they're doing. So if I go to any of the displays here of the block zone displays, we can look at, let's say, Ready 2 sensor. So Ready 2 sensor, this is the specific sensor display, and this allows you to configure the max time and min time faults for the sensors. So these faults are in here as a kind of stupid check of the sensors, because when we look at the actual lift hill up here, if you look at the lift hill up here, we can see that if this sensor is triggered, this sensor should not be triggered within the amount of time that it takes for this train to go up to here. Now I know how fast this motor down here is spinning, so I can predict that it will take, X amount of time for the train to get from this sensor to this sensor up here. And then I can give it kind of a window of uncertainty up here. So basically, min time is the minimum time that I would think that it would take based on the motor speed for the train to get up to this sensor. And I will actually bring that down by a couple 100 milliseconds, maybe a half a second, just, if something weird is going on. But in general, about a half a second on both sides is what the sensors are looking at. So if we look down here at the display again, for Ready 2 sensor, it should take a minimum time of 800 milliseconds to move from the Ready 1 sensor to the Ready 2 sensor based on the motor speed. Now, the max time is 2,000 milliseconds, and that is 2 seconds. So we have about 1.2 seconds total for that sensor to be available to be triggered by the ride. So the max time would be, hey, I did not see the train pass in front of the sensor within that amount of time, so something must have happened in between here, so we have to stop everything and make sure everything's still good. And that's basically how it works. Now from this screen, we can also configure each sensor directly. So we can set front car, set car 2, set car 3, set back car. And this basically just says, which car is in the, it has the sensor detected in the block zone. Now I'm not going to actually click this button right now because it will cause a fault that I'll have to reset. But that is basically what this does, and it allows a user, when it is in manual mode, to manually configure which car did the sensor detect. Now the reset sensor early detect button down here basically disables this minimum time fault, because there are some conditions where if a fault occurs, you have to reset the sensor early detect, or when the sensor is triggered next time, the minimum time won't be enough from the last time you reset, and it will cause a second fault. So this is to keep a second fault from occurring, and you can read more about when you need to actually press that button in the maintenance manual. There are a couple conditions that is needed to be pressed under, just to disable the min time fault so that you don't get a second one. If you don't push that button, all that will happen is a second min time fault will occur when the next sensor is triggered. You just reset it and you can keep going. But that is just there to make sure you don't get more faults than you need. So we can go ahead and click go back, and that takes us back to whatever screen you were on before. And to restart from the faults that we've had here, I'm going to go ahead and push the ride start button, and then I'm going to go ahead and push the lift start button, and we're going to go ahead and start everything back up, and everything's running again. Now, the next interesting thing that the sensors can do is that our brakes are actually monitored. So each one of the brakes has a small sensor that we can see right over here. So this is our pre-lift brake right here, and it is the same as all of the other brakes on the course. And what the basic brake design is that we have our brake shoe here that is going to slow the train down. We have our actuator that opens and closes the brake, and then we have this long piece that is actually connected to the actuator. And this piece has a little part at the bottom that swings in front of and out of the way of this inductive proximity sensor. Now attached to that little piece that's attached to the actuator is a piece of metallic tape, and that is what this sensor is looking for. So when I dispatch a train, for example, you'll see that little bar moves out of the way of the sensor and then closes back on. And what this sensor is looking for is within a certain amount of time, after the PLC requests this brake to open, this sensor must not see that tape again. So when the PLC requests this to open, after a certain period of time, we shouldn't see the tape in front of this anymore if the brake is operating correctly. And then the same thing happens when we request the brake to close. So when the PLC requests the brake to close, we have a certain amount of time that this sensor will wait for this to be flagged. So it'll wait to see this. And if it doesn't see it within that amount of time, it will fault. So to kind of demonstrate that, what I can do is I can actually disable this brake. So I'm going to pull the ground wire out of this brake. So that brake is no longer able to operate. And I'll just kind of adjust that because it twitched a little bit there. And what we'll see here is when I dispatch, it'll start moving, and uh-oh, we faulted. Why? Because we didn't open the brake in time. So what I can do is I can just reinstall our little piece here. And if we want to take a look on our control panel real quick over here, we can see that the ride system detected the fault and is telling us that the brake lift was commanded to open, but the monitoring sensor did not detect the brake opening. So we triggered an auto ride stop. So now that we've fixed the problem, we can go ahead and come back. We can push on acknowledge. The brake is supposed to be closed right now because we're ride stopped. We can go ahead and re-enable automatic motion, re-enable the lift tail. Everything is working again just like normal. And that brake, of course, is just kind of operating as it should be. So the brakes are actually even more advanced than that. And we can see that on our brake run display. So if we go to the brakes and we look at the brake run display, we can see all of this data from the brake run. So what we're looking at on the screen here is the amount of time between each of the brakes here. So this is the amount of time it took to get from this sensor to this sensor, and this sensor to this sensor. And if the brakes are operating properly, we should see what we're seeing here. This time gradually gets bigger and bigger as we go down here. Now, as you can see, it's pretty exponential as we go through here, and then you get this really big number down in this area. Now, why is that? Well, because the train at this point, and this point is uncontrolled and still coming to a stop. Once we've reached this point on the brake run, right about this sensor, we've reached a controlled stop, and we can now start controlling by opening and closing the brakes. So up to this point, opening and closing the brakes isn't really doing much for us. We're just slowing down at a constant rate. And then here, we can start controlling our speed as we come down. And that's why you have this bigger number here. Now this braking profile control time down here is actually the constants that are going into the math that figures out how to slow the train down. So these brakes are opening and closing to keep a generally constant deceleration on the train as it comes down the brake run. And these constants down here, this braking profile control time, is what is going in to do the math to figure out how to slow the train down in a nice, smooth rate. Now, we can see the current status of all of the brakes on this screen as well. So this is, of course, our track, our block zone. We've got our sensors on the top up here, and then we have our brakes. So green means that the brake is currently closed. Now, if I move the train forward in our readies and we see the train move forward, you can see the brakes turned yellow there for a second. That means that the brakes were opened. So when the brakes are commanded to be open, this box would turn yellow. Now, when these boxes below the brakes signify what the sensors are seeing. So when the brake is commanded open, we should see these switch to green because the flag that is on the bottom of that piece that's attached to the actuator should not be seen by the sensor anymore. So that's what this does. Now, down here at the bottom, this brake speed reduction fault time is the time this is the minimum time that it should take to get between these sensors to make sure that the brakes are slowing down at a proper rate. So if the train is going faster, which should signify a lower number through here, we should trigger a fault to say, hey, this brake here, like if this brake ever saw a time under 30, which I have seen before when this brake is fully open, it would say, hey, whoa, this brake is not operating properly at all. We need to take a look at this brake and fix it before we send the next train. Now, there is a safety factor developed into the actual brake zone. So we can have one brake fail completely, entirely, just totally not even there, and the train is still able to stop properly. You can even have two brakes fail, and it will be hanging off the end of the block zone, but we are capable of fully stopping the train within the block zone with 4 brakes and capable of stopping the train without it rolling into the next block zone with 3. So that's just a little bit of a safety factor that's developed into the system for a little bit of extra added redundancy. So now also on this screen you have the open brakes down here, and what I can do is I can go ahead and put my key back in and turn it to manual, and these open brake buttons allow me to manually open each of the brakes. So if we look up on the brake run, we can see that I'm manually actuating brake 5 open and closed. And the block system is also active here, so if you had a train in that block zone and you tried to open this brake down here, it would not open because we cannot allow the train to move into the readies where there's another train there. So that's just a little thing for safety there. All right, so we're looking at the control panel now, and we're going to talk a little bit about the faults that can occur on the buttons. So the important thing about the buttons is that we want to make sure that they're actually being pressed, because we don't want to send a train, like dispatch a train when there's the button's actually not being pressed. So the way that we do that is there are two contacts on every button. So what the software is looking for is for these contacts to flip. So this right now, because the button is up, this wire has positive voltage in it, so the circuit is connected, while this wire right here is not connected. And right now the software says, good, that is working like it should be. Now, if for whatever reason one of these contacts fails in there, which we're going to show in a second, we want to fault and make sure that nothing happens. So I'm going to go ahead and dispatch just like normal and send the train. But now what's going to happen is I'm going to go ahead and fault the ride stop push button. So if you push the button in just the perfect way, you can get the ride stop to fault. Now, we faulted with a major fault. Why is this a major fault? Well, because it's a stop button. So we need to make sure that everything stops in the case of this button failing. Because what the system saw was that one contact came out, but the other contact didn't turn on when I pushed the button. And so we said, okay, we've got a problem with this button, we need to stop. So we've stopped on this push button. So what we have to do in a major fault condition is we turn it to our manual mode, where the maintenance guy would come on over, double check on the button and say, okay, it looks good. And then we push and re-acknowledge that the button is good to go. And we have to acknowledge in maintenance mode to be able to do that. And we switch back to automatic, restart, and we're running again. Let's say we had a fault on the dispatch button. Well, I can push down on the dispatch button and you can see a fault has happened, but everything on the course is still running. And you're asking yourself right now, wait, I thought when things faulted, everything had to stop. Well, not necessarily, because in this case, the only thing that I'm really looking at that has a problem is the fact that this button failed, which is not really a big problem for the rest of the ride operating. Like, I can still stop the lift, I can still stop the train here, I can still emergency stop, I can still do all that. I just can't send a train. So the only block that's really has a problem is the station block. So we're not going to let the train move into the next zone. Is the key of this fault. So to reset a minor fault, all I got to do is push acknowledge, because it's a minor fault, and minor faults can be acknowledged even in automatic mode. So we just go ahead and push that and restart. And now we have dispatch enabled again to go ahead and dispatch a train just like normal. And as you can see, it's running as it should be. So we've talked a lot about faults here, and some of the stuff that we would want in the real world is to be able to analyze what are the most common faults. So we can actually do that here, and we can go to our alarm history. Now on the alarm history display, we can see every single alarm that has ever turned on this thing. As you can see, I have done a lot of testing. Over 987 faults have been triggered. There are actually a couple hundred different faults that can occur on the ride that are all programmed in to activate in their certain condition. And so if you ever wanted to clear the alarm history, you could click that button down there. I'm not going to do that because that would clear all of the logging that I have set up, but it is an option to do if you really wanted to. But yeah, this is the alarm history screen. You can click on an alarm, look at it in a little bit more detail. Like that was the e-stop or the dispatch button faulting. That was our ride stop button faulting, et cetera, et cetera. So yeah, I can go back to our main screen and keep on going through what's going on. So one of the biggest features that we've added on here in the past couple weeks is our unsupervised show mode feature. The unsupervised show mode is in here for operating in conditions where you would be leaving this thing alone in a museum for like a long period of time, where you're not going to have someone like me standing here explaining what to do and how to do it and all that stuff. And basically this is to set up the ride to operate and display itself for lack of better terms. And to enable that, you go ahead and just click the enable button and it turns green. So now we are in unsupervised show mode. Now, nothing's going to change right off the bat that you can see, but we have disabled a couple features on the ride because we are in unsupervised show mode. And one of those features is the ride stop button. So the ride stop button would normally stop the ride entirely. But if we push right now, it's not doing anything. Even when I send a train, it's not doing anything to stop the ride, because we do not want to have guests coming up and stopping our show mode sequence. Also, our lift stop, you can see, doesn't work anymore. Why? Because we don't want guests to stop our lift either when we are running in our unsupervised show mode. Also, no matter what setting you had the gates and restraints on, they are now forced to be in the automatic mode. So every time the train parks, they will automatically open both the gates and the restraints, so you'll have to close them. Now, also in this mode, the dispatch button is now no longer a press and hold. You now no longer need to push and hold the button to activate motion within the station platform. All you have to do is momentarily tap it, and it will automatically shift the trains through the station platform all by itself. Now, another thing that you no longer have to do is use this transfer display. In fact, you don't even have to switch out of automatic mode anymore to use the transfer. All you have to do is go back to your USM configuration display and say, hey, I don't want that train in the station to be running anymore. That's easy. We just click transfer off, and now the train will automatically transfer off the track all by itself. As you can see, I am hands-free. It is doing it all by itself. All right, and then let's say, oh, nope, I made a mistake. I want to put it back on. All we got to do is put transfer on. It turns green. The track switch starts moving, and it automatically shifts the train back onto the track, completely hands-free. So another feature of automated show mode is the enable auto dispatch feature. So you can enable auto dispatch by just clicking on the enable button here, and that enables the auto dispatch interval. So this is a time in milliseconds that you want the train to send in. So right now, it is set to send a train automatically by itself every 30 seconds. So after a 30-second timer counts down, it will automatically dispatch the train. And we'll see here in a second as soon as the 30-second timer counts down to 0. Now, we also have enable/disable auto transfer demo mode. If you look back down here at the screen, and enable/disable auto transfer demo is here to show off the transfer table all by itself. So this can be activated independently from auto dispatch mode. So you can have this disabled but this enabled, and that means that every 3 cycles it will automatically transfer a train off. Now we'll have to wait a couple cycles for that to happen, so I'm going to talk about a couple other things in the meantime. On the operations display here, we can go to a brand new operations display that should be used in automated show mode only. And this shows the same operations display that you saw before, but with a couple extra things. Instead of our automatic manual restraints and gates, we now have the time till next dispatch, the cycles till the next transfer demo, and the next train to transfer. Now, the cool thing about the transfer demo mode is that it will actually ensure that all the trains that are enabled on the track will get even wear. because when we're running thousands of cycles per week on the model, we want to make sure that all of the trains are evenly worn in. So the software will automatically choose the next train to be transferred off in automatic transfer mode. So the Icarus is the next train that has been selected by the control system to be transferred off, and we'll see that in just a moment because we are on our last one. So there are 0 cycles till the next transfer demo. Now you notice I have not touched any of the push buttons at all in the time that we've been sitting here talking. It's been running all by itself. And as soon as this train comes back and parks in the readies, we're going to see this train here roll out, get sent around the course, and then the train that's currently in the station, which is the Icarus, to be taken off and put in the storage block. So we're going to see that automatically occur right now. As you can see, it's identified where the train is on the storage track. It doesn't matter where that train is, it will still pull it off automatically. And we just wait for it to move all the way down and park on there and transfer off all by itself. And then as soon as it clears that zone, our next train from the station that we're taking off is going to roll on, and it'll automatically transfer off. Now the system will tell it to park right here because that's the closest block, and that'll help speed up the transfer demo on the next time. So let's say, just for kicks and giggles, I'll actually show y'all. What we're going to do is we're going to show what would happen if a train took too long to get around the course. So in the case that a train, let's say, is just not doing well, the bearings are starting to run out on the train, and it's not performing the way it should. Well, we can actually we can actually cause a fault on that train for that issue. So I'm just going to grab the train here for like a half a second as soon as it comes over the top. And then it'll make it around the course. But it took too long that time. And if we go back to the main display and go to system stats, we can now see that our train that just went around took 3,578 milliseconds to go, and it is now disabled. Well, what does that mean? That means that an auto transfer demo has been automatically activated to move an enabled train onto the track and take off that disabled train. So as soon as this train clears and comes over, that train will advance and be pulled off for maintenance purposes. And we'll see that here in just a moment as soon as that stops and we're rolling. So now future auto transfer demos will not be able to use this train, and automated show mode in general won't be able to use this train. You cannot transfer that train back onto this track because it is considered disabled by the ride system right now. So on the next transfer sequence, we would only see this train transfer off. Now we're in 2-train mode, which basically the pattern has shifted for what the transfer demo looks like. So in subsequent transfer demos, what you would see is this train, whatever train is selected to come off, would transfer off immediately. And then you would see 3 cycles in single train operation mode. And then when the counter for our automated show mode that we configured here, this auto transfer interval, whatever that counter is, whenever that counts down to 0, that's how many cycles we would run for single train. Then what would happen is the train that was sitting here would get transferred back on and would run 3 cycles in 2-train operation. And then we would transfer off the opposite train to keep ensuring that we have that even wear on all of the trains. So let's take a look here and see how long. Oh, so our next train will be this train. So you see our training station is endurance. The next train to transfer is endurance. So that's what we are looking for. So we just have to wait until the train comes back to the ready break, and we'll see a 2-train enabled auto transfer off. As we can see, it transfers off. It'll move the disabled train forward to give that train some room. And we can see we have parked both trains on our storage segment automatically. All right, so we've seen the train get pulled off the track if it's disabled. We can also, if it's automatically disabled by the ride system, we can also manually pull the train off, disable it by ourselves. What we do is we go to System Statistics, and we go ahead and go over to, let's see, what's in the station right now? Endurance. We're going to go ahead and disable you. And so it is now disabled, so that train will be pulled off the track automatically and put on our little side table here. So now we have 2 trains that are disabled by the ride system. And it'll transfer back to the same spot, and now we're in 1 train. So now, even though we are in, we have enabled transfer demo, every time it counts down from 3, it'll literally just reset it, because the only train that's left is the one on the only train that's running is the only one that is able to run on the track, so it will never do a transfer on its own anymore, even when that counts down to 0. So that is the basics of enabling and disabling trains. And then just to re-enable the trains, we go on back to the train display, and we go ahead and click Enable Train, and so on and so forth with, let's see, gotta go back. Enable Endurance. All right, we're enabled on all of our sets. So all the trains are enabled again. And now the system, over time, will automatically, in the auto transfer demo, transfer the trains back on and put them back in their normal sequence of being taken on and off in a normal interval. If we want to, I'm going to go ahead and disable these and show you some of the buttons down here. So in automated show mode, we also can automate part of the startup process. So if we wanted to put all of the trains that are enabled onto the track immediately, we can push the startup button, and the startup button will automatically transfer all the trains that are enabled onto the track all by itself. And we'll see the next train as soon as the motor stops. Okay, we'll come back over, pick up the next train all by itself. And after this is done, you would want to run your normal blocks test, just like always, before you start running for the day. But this just makes it easier for you to put all the trains on the track without having to go through the transfer track control display. At the end of the day, the shutdown procedure says that you should put all of the trains onto the storage track, because it's just a best practice to put all the trains away at the end of the night. We do have a button to do that, and it's called the Put in Bed button. So we can go ahead and click on the Put in Bed button, and that will automatically transfer all the trains off the track and put them in their storage segments over here. Now, another thing about the Put in Bed mode is that this assumes that you will probably be powering off the ride at the end of the night. So this will also save all of the data that has been collected on these trains for the day onto the SD card that is inside of the PLC. And this is just in case you have a battery problem on the PLC and you lose the memory that is on that is saving the tag values of the PLC. This will enable you to, the next day, if let's say you had a battery fault on the PLC and you lost all your data the night before, and you want to be able to show people like all the cool data that you collected the day before on all of your trains, we can go ahead and load all that data back into the ride, and that is super easy to do. All you do is, when all the trains are in these storage blocks over here, you go to main, go to your system statistics, and you can click on the load data from SD card. And all you do is click on that, and it will load all the data.
it just loaded all the data, but of course, because we just transferred all the trains off, nothing changed here because it was all the same data. But if you did, for some reason, lose all your data and all of these are empty, you just click on that and it loads all the data automatically from the SD card that you saved the night before. So it is a best practice at the end of the day to put all your trains away on the storage track using the unsupervised show mode put in bed button, because that will save all your data logging data and make sure you don't lose anything in the case of a unrecoverable fault on power up on the PLC. So when you're on the unsupervised show mode operations display, what we're going to want to do is, if this is just sitting out there, we don't want guests to be, playing around with any of the other features on the HMI. So we can actually lock the guests out from navigating using these buttons to go to other screens in the HMI. And we can do that by simply going to the log on screen. And we can type in, USM, which is our user for unsupervised show mode. We can click log on, and you'll see those buttons have disappeared over here. Now, if I wanted to log back on, I can log in to my username, which is Jared. Okay, and then password, and now hit log on, and now I'm logged on, and you can see these buttons have appeared in the top corner once again to allow me to navigate off the screen and back to the main menu to do other things.
Alright, so we're going to take a quick look at the electrical system on the model roller coaster. So we're going to start in the top up here. This is our PLC. It is actually a safety PLC, which is a little different than a normal PLC. We not only have one processor here, we have two. We have our main processor here that is running the program, but we have another processor here that is also running the program, and these two are checking each other to make sure that they agree on what should be happening out there. This is adding an extra level of redundancy to the system to make sure for 100% fact that what is going on is actually what we think is going on. As far as these sensors go, it's all inductive proximity sensors, a little of what I said already. They're detecting metal. Of course, when I put my finger in front of it, it's not picking me up at all. All of these sensors run back to these three modules on the PLC, but they take quite an exciting route to get there. What they will do is all of the sensors run through little holes on the table here, and they go down under the table.
So each of the sensors comes down into these terminal blocks. And as you can see, as they come out of the sensor wires, they split into three different wires. One is ground, one is VCC, which is going to be the positive voltage, and then the last one is the signal wire, which is basically whether the sensor is being triggered or not. And they split into these terminal blocks. And these terminal blocks are here for ease of maintenance, because we want to make it easy for someone to be able to replace a sensor. We don't want them to have to actually rewire the entire path of the sensor all the way back to the PLC every time one breaks. So all you would have to do is pull these little tabs down and replace the sensor. The sensors all run out of these terminal blocks, down and through these wire runs, up and into the main PLC rack down here. And now if we go back up on the table,
we can see the sensor cables coming up from under the table through this wire run, through this wire run, and splitting back out into their three wires here, where they go into this set of terminal blocks. Now this set of terminal blocks basically collects all of these wires into a single cable right here that then gets fed up through here and into the PLC input module, which is located 1, 2, and 3 here. And that's basically how all the inputs work. Now, to be able to communicate with all of our outside devices on the ride system, we have our communications network set up here. This is a standard Ethernet switch that allows me to connect my computer over there and all of the other devices onto the network. Some of the devices on the network are our control panel over here. Now, a couple of quick things about our control panel. We're able to actually detach our control panel just by unhooking this little
Ethernet cable here and this 24 volt connector right here, and that will detach the control panel for you to move it. Underneath the control panel we have our rack of point I/O that is enabling it to, that is taking all of the inputs in from the buttons, all these green wires here, and then sending outputs through these red and black wires here to all of the lighting on the control panel. And that's all being controlled on the PLC through the Ethernet network. This is of course the back of our HMI panel view, and then of course the back of all of our buttons. Another device on the network is our motors, and our motors are actually kind of cool because they're emulating a variable frequency drive. Now VFD is what allows the motors to change speed. It just changes the frequency of the output signal to the motor, and these are pretty much the same, except they work in DC rather than AC. And so these DC drives, quote unquote drives, are really just motor drivers, just H-bridge motor drivers that are controlled from the Arduino. Now the way this system works is the Arduino is connected to the PLC through the Ethernet network using software that I wrote on the PLC. So the PLC will send the speed information for each of the motors in a packet through our Ethernet network down to the Arduino, where the Arduino decrypts the packet that the PLC sent and translates it into speed data that these controllers can understand. That data is called pulse width modulation signals. That PWM is fed into each one of these motor drivers, which then sends out a higher voltage frequency to each one of our motors on the course, and depending on the frequency it changes the speed of the motors, and that is the basics of how this works. Now the PLC is also sending information about whether to open or close our brakes, and that's being sent in the same packet that is also being decoded by the Arduino, and is being sent to this last controller on the end here. This last controller on the end is our servo driver, and it drives all of these little servos here through also pulse width modulation signals. Now, to supply power to the entire machine, all you got to do is plug it in through a standard wall outlet power supply. That power gets fed into these terminal blocks that splits it out into 4 different power supply cables that run into the bottom of our main power supplies. So the PLC power supply, this guy, which is another power supply, and then our other power supply. And that is all, the cables before it all runs in there, runs through our main ride circuit breaker, and by just flipping that switch down you can kill power to the entire system in general. Now when it comes out of the power supplies as 24 volt DC, it runs into these blocks right here, which are electronic circuit breakers, and this is making sure, protecting against short circuits in some of our wires running into some of our more mission critical devices. For any device that doesn't run on 24 volts DC, it is then one more time brought down to the correct voltage through those boost buck converters that are changing the 24 volt input down to 5 volts for the Arduino and all of the Arduino control stuff, and then 9 volts for our motors, because these motors run on 9 volt signals. So yeah, that is our electrical system in a nutshell. So the entire roller coaster is designed to fit through standard commercial doorways. It's approximately 29.5 inches wide, which is 2.5 inches less than a standard commercial doorway, which should be at least 32 inches wide. And that was a big stipulation because we have to make sure that we can move this through commercial buildings like schools and museums, etc., etc.
One of the big issues that I faced during the construction of the roller coaster was the onset of the COVID-19 pandemic. And that meant that I could no longer access the CNC machines on campus. And so, of course, that made drilling all the holes for all the supports very, very difficult. Because in the 3D model, it is very important that all of these supports be drilled exactly in the right spot. And originally I was going to put this whole platform on a 4x8 CNC machine that was just going to go through and drill all these holes in the right spot for me. But now I don't have access to the machines, so I had to come up with a solution to fix that. And what I came up with was actually laying down a grid of sheets of paper with drawings that show where these holes were supposed to go. And once all of the sheets of paper were laid down in a grid and glued down using little glue dots, I was able to go through and drill each one of the holes by hand in exactly the right location on the model. And then when I took all those sheets of paper off, I had the holes all drilled perfectly, and then all I did was screw all of the supports down in the right spot, and that's how we got this very precise model without using any advanced machinery for that part. So another one of the problems that I faced with COVID-19 was the fact that the budget for the roller coaster was cut pretty significantly in the fact that I was no longer able to buy some of the injection molded components that I was originally going to purchase. And a couple of those are the actual gears. Every single gear on the model roller coaster is a 3D printed part. It is not an injection molded plastic piece like it was originally intended to be. And with that came a whole new group of challenges, because components that were originally designed to be injection molded do not work as well for 3D printed parts. So a lot of these components were modified quite a bit, including these, which actually have a flat base on them as opposed to having these little circles that push out. And that was because these little gear teeth needed to be extremely precise. Another thing that I had to do was these tiny gears were not going to be able to have the tolerance to be able to slide over these axles as easily. So I decided, well, why not design the whole axle to have the little tiny gear on it? And so what I did was, this gear axle assembly here is not an assembly, it's a fully 3D printed part. So the gear is actually fused onto the axle itself, and that's just part of the design. So yeah, it was all about redesigning these injection molded Lego parts to work as 3D printed components that could be 3D printed and come out fairly high quality to be able to operate at the frequency that we want. So one of the biggest issues that I had when I was building the model were the design of these lift pucks. And the problem is that on the actual 3D printed component, if you can see, this is a very thin area. And of course you have layer lines with the 3D printer building the part in this orientation. And the layer lines through here are so thin that as it goes around many times, stress fractures can form in these layer lines and actually cause the little parts to break off, just kind of like that right there. And when they're manufactured in this way, the components break off, and you see they break off right in that top part where the layer lines are super thin. And so that was a huge problem that I had, but I was able to come up with a solution. And this is the great thing about 3D printing and rapid prototyping in general, is the fact that you can go in and trial and error many times. And I found that printing them in this orientation worked really well. And why is that? Well, because it moves it creates a bigger area where the part was breaking before, which was here, which is where we're exerting force down this way on the component as we're trying to
basically rip it apart as it pulls up the lift hill. And so having that extra space is allowing these components to last way longer, about 3 times longer than they would have if they are printed straight up. And that was something that was really interesting to me. Just one of the cool learning things that I had discovered along the way, building this thing, how different orientation can really affect the strength of a component that is 3D printed. All right, so this is how I actually designed the roller coaster. I actually went in first and made a model in no limits, and this actually has a custom friction profile that I developed based off of data from the real trains, so that I can ensure that the train would make it through the course every time. We can actually see if we leave the editor here and go to running the roller coaster, we can actually sit down and take a ride. Now this doesn't work the same way that the stock No Limits program would work. Usually this would be a lot faster, but because of the way the trains perform on the track, we have to change the way the friction shows up in the actual simulation here. So that was modified to ensure that the trains would make it through every single time. So of course this is the on ride data, but we can come off ride and we can check out, see the train. In real life this would be about 150 feet tall, but of course it's scaled down in our model to be about 37 inches from top to bottom, and we can see the train go through the course. Takes a lot longer because of course this is a lot bigger. But yeah, that's the model in No Limits. So when I leave No Limits, I can actually export all of the data of where the track is and the bank angles and all that stuff, and it basically exports 3 lines: the center of the track, and then that right rail and that left rail. And then from that, I can split it into separate files, and those become our track pieces, and those are brought into Fusion 360, and this is an example of one of the track pieces that I brought in. And as you can see, we have the center line and the left and right rails of where the track would be, but we have the actual spine, and this is what's 3D printed. And then the distance from here to here is the amount of distance that from the surface of if we look over at the roller coaster, this white part up to this black part. And so these rails are represented by the dotted lines here on the track. And then of course the absolute center is that center line right there. Once I finished all of these little single track pieces, I was able to come in and actually build the entire model. And this is all the track pieces put together with all the supports. And of course we went through and clicked on each one of these and exported and 3D printed every single one of these components over the period of about 3 months. So after I exported the files from Fusion 360, I brought them into a software called Simplify 3D, and this is where I created the actual machine code for the components to be built on a 3D printer. So each one of these little supports were actually custom placed to ensure that the track component would be created properly. So you can actually go in and Simplify 3D and go in and click where each support you want to put each support. And that was a very useful piece of this software to make sure that the 3D printed components are printed with a very high quality. So yeah, but on each one of these, if you look very closely here, you can see each layer that the printer printed as it built the component up. And these were actually 3 track pieces, which are actually sitting over there on the turn. That was the 3 track components that turn into the transfer track there. That is represented by here. And yeah, this piece took about 24 hours to print total, and there were many of these that had to be done. So yeah, it was quite the process, but this is how it shows up in the computer aided design. And I was actually able to do some some stress tests on some of the components to ensure that, you know, the forces are supplied to the structure in the right way, and that everything would be very firm and rigid when it was actually built in the end. And it's really great to be able to visualize and simulate the structure beforehand, so that, you know, you don't want to spend 3 months printing and then you get here and the thing doesn't work. So yeah, that's how it was designed. All right, so this is the actual program that's running on the PLC over there. And of course, it's really hard for, you know, a normal user to be able to discern what is going on from, you know, looking at ladder logic. So what makes it a bit easier is if we have a human-machine interface to be able to visualize the data that's being collected by the PLC program. So I created this HMI screen that basically shows, you know, the overview in this case, but this is how I designed the entire application. And it's literally the tags in the PLC that are tied to the actual objects that I've, you know, created on the screen here. So this one, for example, is HMI current hour capacity. And as you can see over here, when we look at the screen, we can see that our current hour capacity right now is 0. So this is how it relates to the tags in the PLC. And then as far as the different colors that you see on the screen, I've created several add-on graphics, which are basically global objects that relate to the user-defined types that I made. So, for example, each one of the sensors has their own user-defined type. Let's see if I can find it. Track sensor input. So all of this data can be really kind of shrunk down into just displayed on a box, which is this right here. So this is tied to this expression that then comes up with a number that then displays which one of these colors is shown on this box. And then using these global objects makes it a bit easier when you're going in to create the full screen, because all I have to do in this condition is just tie the tag that is associated with this user-defined type. So all I have to do is put in, you know, track 1 sensor into here, and then the expression is evaluated. And even in the case of going to the sensor screen, so the sensor menu display that you see that we looked at earlier, this is all defined. This entire screen, all that happens is when I tap on one of those squares, it passes in all of this information here into this screen and displays it in a way that is easy for a user to understand. And that's the whole idea behind this human-machine interface application.
And that's about it. Thank you so much for checking out the full demonstration video of the model roller coaster that I've been building. It's been a super fun time putting it together, and I can't wait to get started on the next one.